basic two-dimensional geometric transformations. In this, we'll discuss two-dimensional rotation. Now you can see here a point P whose coordinates are x and y. It has been moved to a new point Q whose coordinates are x dash and y dash after a rotation of angle theta. Now you come back to P. You can see it is at a distance of r from the origin and it is making an angle of phi with the x-axis. After it moves to the new position Q, the distance remains the same from the origin and the angle with the x-axis has increased to phi plus theta. Now you can see from the right angle triangle POM we can find x coordinate and y coordinate in terms of r and phi that I am showing here. From the right angle triangle POM, and cos phi is equal to x by r, and from that x equal to r cos phi, and that is the equation number 1, and similarly y also in the equation number 2. Now again you come back to the diagram, and from the right angle triangle QON you can find x dash and y dash by this equation, and the total angle with the, already I told, angle with the x coordinate is increased to phi plus theta. Therefore the cos phi plus theta is equal to x dash by r, and from that we can find x dash, and already you know x r cos phi I can replace with x, and r sin phi I can replace with y, and therefore the equation number 3 giving the x coordinate of the new locations of the point, that means x dash, and in the similarly I can find the y dash also, and that is been shown in the equation number 4. Now this equation number 3 and 4 can be represented in the homogeneous coordinate matrix form. Now this is the transformation matrix, and if you multiply this transformation matrix with the original coordinate, you will get x dash and y dash exactly as in the equation number 3 and 4. And now I'll take a example here. At a point 3, 4 is rotated through an angle by 30 degree, and therefore at the equation number 3 I can find the new coordinate after rotation of the new coordinate is a x dash. I can find with the formula which is shown in the equation number 3 as found to be 0.6, and equation number 4, applying equation number 4, I can find the y dash, the y coordinate of the new locations of the point, and that is found to be 5. Now you can see that in the homogeneous coordinate matrix form also, whatever I shown, that if I replace theta by 30 degree and in the matrix and the x if I replace by the original coordinate 3, 4, and the y you know already, this is the one-dimensional additional one-dimensional has to be given in the homogeneous coordinate form. Then you can find that after multiplying this transformation matrix with the x coordinate, you can find x dash, which the new coordinate is found to be 0.6, and the new coordinate y coordinate is found to be 5, and that whatever we found in the equation number 3 and 4 by applying the equation number 3 and 4. And what I wanted to show here, that if you do not know the final coordinates of after movement, that means x dash and y dash, you can find with the help of a homogeneous coordinate only if you know the angle of rotations. That has been shown in this example. Two-dimensional rotation about pivot point, and that we'll discuss now. Now you can see in this diagram R is the pivot point and the coordinates are XR and YR, and the point P will be rotate about R, and it will be rotated to a new point Q, and you can see here it is rotated to new point, and already you can see the coordinate of P is xy and coordinate of Q x dash and y dash. Now you can see from the triangle PRN, right angle triangle PRN, if you can see that RN we can find x coordinate x minus of xr. That means the xr it is the Rn. With this concept, you can see here from this right angle triangle PRM, and cos phi equal to x minus xr divided by r. And in this way, r cos phi equal to x minus xr, I am representing in the equation number 1. Exactly in the similarly, y minus yr can be represented as r into sine phi. Now again I come back to the diagram. Now you can see after rotation the triangle QRN, in this right angle triangle QRN, you can see Rn is equal to x dash minus of xr. In that way I can find from here, I can find now, because the after moving the angle has been increased to phi plus theta, and therefore Rn already I told x dash minus xr divided by r, because r is not changed, and therefore I can find this x dash equal to, by this equation here, one thing, r cos phi has been replaced by x minus xr from the equation number 1, and we got it that new locations, the x coordinate we got the equation number by the equation number 3. Exactly in the similarly we can get the y coordinate of the new locations by y dash by the equation number 4. Now we'll discuss two-dimensional composite rotation. That means a particular point has been rotated through an angle theta 1, then again it has been rotated through an angle theta 2. Then what will be the final coordinate of the point? That is our discussion. Now this matrix, you can see we are considering the homogeneous coordinate matrix form. This matrix, this is a transformation matrix for the first rotation of theta 1 of the point xy. And this is the matrix, transformation matrix, which signifies the second rotation of angle theta 2. And then you can see this is the matrix which is the showing the original coordinate, and this is the final coordinate we are showing. And again I repeat, this is the matrix corresponds to the first transformation, that it's rotated through angle theta 1, and this corresponds to matrix that second rotation by the angle theta 2. Now if we multiply these two matrix, we get a single matrix that I am showing here, and this is the single matrix we'll get, and that this is the single matrix. These two transformations are being combined together, and we got a single transformation matrix. And here you can see that these two angle of rotations are being added together. Here two angle of rotations are added together, and therefore you can see with the homogeneous coordinate matrix forms, and that multiple transformations can be combined into a single matrix form. That I wanted to show here. Now we'll discuss two-dimensional rotation about a pivot point and to express them in homogeneous coordinate matrix form. If you want to express them in the homogeneous coordinate matrix form, then you have to proceed some operations, and that is the steps has been shown here. The first, translate the object, that means bring the object so that the pivot point is at origin. That means pivot point has to be brought to the origin first, then rotate the object. After rotation is over, then you translate the pivot point to its original position. That I am showing in the diagram here. You can see that xy, this dot here xy is a pivot point. The first step is to bring that to pivot point to the origin along with the object. Then you rotate the object. After the rotation is done, then bring the object along with the pivot point so that the pivot point is at the original position. That is the procedure. And here we are showing here now in the matrix form. Now you can see this is the original coordinates and this is the final coordinates. And here already I told this is the matrix which is responsible for translation from the pivot point, it brought it to the origin. And that is the rotational transformation is happening about the origin. That means object has been rotated. And this matrix is responsible for bringing the object from origin to, so that the pivot point has come back to its original positions. And therefore, this multiplication of these three matrices is required. Now, you can see here that if we convert these three matrices into a single matrix. First, we multiply these two matrices and we got this matrix, and then this matrix has been multiplied with this matrix. We got the single matrix. Therefore, these three matrices are being converted into a single transformation matrix. And if this is the single transformation matrix, if it is multiplied with the xy coordinate that I am showing here. Now, this is the after simplification, slight small simplification, we got this ultimate the transformation matrix. Now, this transformation matrix, if we multiply with this x coordinate, we'll get the x dash and y dash. That means after transformation, what are the coordinates, we'll get it. And another important thing, that will what we got for a pivot point in the equation number shown in the equation, and that will give you the exactly the same equation if we multiply this and this. And that is a good point of the homogeneous coordinate transformation.